Gujcet 2014 physics paper solution. Question number 1. Electric field E, we have to find out dimensional formula of electric field. So electric field E is equal to force upon charge. Dimensional formula of force is m1L1T minus 2 upon dimensional formula of charge, that is A1 into T1. So if we solve this to m1L1 T minus 3 into A minus 1, this is the answer of our first question. Now question number 2. Electric field, here particle having mass m and charge q is at rest. On applying uniform electric field E on it, it starts moving. What is kinetic energy when it travels a distance x in direction of force? So we have to find out the final kinetic energy of charged particle, and work is done by the uniform electric field. So if we apply relation delta K is equal to W, then work done by external electric field is equal to Q multiplied by change in potential. So K final minus K initial is equal to Q into E into D, work done by electric potential. Now Q, electric field is given E, distance is given x, so if you multiply them, answer is Q into E into x. Now we'll take question number 3. Question number 3. Two spheres of same radius and same mass are suspended by two strings of equal length from same point. System is given like this. Two spheres of equal mass and equal radius are suspended by two strings of equal length from same point in such a way that their surface touch each other. Now on charge Q is equal to, charge Q is given 4 into 10 raised to minus 6 coulomb. This is deposited on both of them. Now they have same size, so charge will be equally distributed. That means charge on first sphere is equal to charge on second sphere is equal to Q upon 2, which is equal to 2 into 10 raised to minus 6 coulomb. Now they repel each other in such a way that at equilibrium the string is at 60-degree angle. So now if we find out repulsion condition, these two spheres repel each other due to positive charges deposited on them. Now angle between them becomes 60-degree. Suppose this is first sphere, this is another sphere, angle between them is 60-degree angle. Now system is in equilibrium. Suppose they have positive Q charge and mass m. Now how many forces are acting on the system? So first force is in downward direction, which is gravitational force. Another force is electrostatic repulsion, which is in this direction. Third force is tension force, which is along the string. This is tension force. Now system is in equilibrium condition. Length is given here 10 centimeter. This distance is 0.1 meter. So this distance is also 0.1 meter. And here this will form equilateral triangle. So this distance will also be 0.1 meter. Now this angle is 60-degree. This is also 60-degree angle because opposite sides are same. So if we take component along this direction for tension, it will be T cos 60, and in this direction the component will become T sin 60. So for equilibrium condition, if we balance forces, equilibrium, vertical forces is, if we balance, then T sin 60 will be equal to mg, and balancing horizontal forces T cos 60, that will be equal to electrostatic force. So if we take ratio of these two, then 1060 will be equal to mg upon Fe. Now we have to find out force, mass m. So m is equal to, now 1060 is root 3 multiplied by electrostatic force divided by g. So if we substitute values, m is equal to root 3 multiplied by, this is k into q1 into q2 upon r square, and g is already in division, which is, we can take 10. So 1.73 divided by 10 into 9 into 10 raised to 9 into, charges are same, 2 into 10 raised to minus 6 whole square divided by, distance is 0.1 square, this will be 10 raised to minus 2. So this is 1.73 into 2 into 2 4, 4 into 9, that will be 36 into 10 raised to, this is minus 3, minus 12 and 9 is minus 3, divided by 10 raised to minus 1. So here if you solve this, you will get answer which is equal to 0.6235 kg. So option B is correct here. So this is solution of question number 3. Now we will solve question number 4. Question number 4. Electric field produced due to an infinite long conducting wire. We have one infinite long conducting wire which is uniformly positively charged. We have to find out electric field is given here. The charge at distance, perpendicular distance 2 centimeter is from here, suppose distance is given 0.02 meter, and at this point electric field is given 3 into 10 raised to 8 Newton per coulomb, and we have to find out linear charge density lambda. So electric field due to linear charge density lambda, E is equal to lambda upon 2 pi epsilon 0 r. So this is formula 1 upon 4 pi epsilon 0 we will write, multiply by 2. So multiply by 2 and divide by 2. This is K. So K into 2 lambda divided by R is equal to E. That means lambda is equal to E into R upon 2K. E is given 3 into 10 raised to 8. R is given 2 into 10 raised to minus 2 upon 2 into 9 into 10 raised to 9. So this 2 will get cancelled here, 3 in division, so this will be 0.33 into 10 raised to minus 1 minus 3, this is total minus 3, and coulomb per meter. So here in answer 333 microcoulomb per meter. Option A is correct. Now we'll solve question number 5. In question number 5, we are given two identical ring of radius capital R. Both are identical, they have same radius capital R. They are kept on same axis at distance R apart. Distance between them is also R. This is for center of first one A, center of second one is B. Now if the charges present on them are 10 coulomb and 5 coulomb respectively, here Q1 charge deposited is plus 10 coulomb, positive charge is deposited all over the ring, and similar way here positive charge Q2 is plus 5 coulomb is deposited. Now calculate the work done in moving charge small q from center of one ring to another ring. We have to shift charge small q from point A to point B, and we have to find out work done, W. Now work done is equal to the charge which is being shifted multiplied by change in potential. That means Q into potential at A point minus potential at B point. Now how to find out potential at A point? So potential, if we find out at A point, so potential is produced by charge Q1 and Q2 both. Now for charge Q1, the distance is R. So K into Q1 upon capital R, plus for second charge it is K into Q2. Now distance from Q2 charge to A will be this one. So this is R, and if we write this, that will be R square plus R square, Pythagoras theorem. So it is root 2R. So upon root 2R. Similarly, if we write VB, then it is K Q1 upon, now this distance will become root 2R, and plus K Q2 upon R. So we'll take difference of these two, VA minus VB, which is equal to subtraction of these two, K Q1 upon R common, 1 minus 1 upon root 2 in first case, plus here K Q2 upon R common, 1 upon root 2 minus 1. So this will be k q1 upon r minus k q2 upon r. This will take common 1 minus 1 upon root 2. So this is VA minus VB. So if we put over here, so W is equal to Q, K upon R common, Q1 is 10 minus Q2 is 5 bracket, this is 1 minus 1 upon root 2. So now 1 upon 4 pi epsilon 0 into small q upon r into 5 in bracket 1 minus 1 upon root 2. So this is a minus b. Now actually work done is final minus initial, so we have to take negative sign. So this will be minus 5 into q upon 4 pi epsilon 0 r 1 minus 1 upon root 2. So this is answer of question number 5, and option B is matching. Option B is correct answer.